as usual now, we have Explorer. You click your Explorer. So now, it's loading. Yeah, fully loaded. You can open, the good news is you can open several Explorers at the same time. You can see here I have multiple Explorers open. It means I can put one data here, I can put another data here, and I can be running multiple experiments at the same time. I have the diabetes data, I have the hypertension data, I have the stroke data, as the case may be. But depend on the power of your machine. If your machine is very weak, you don't do that because that is going to clog the whole thing. Now, our WEKA is open now. So we are ready to go. So the first step, you can see here, you cannot even use classify. So because you didn't select data. So now let's open the file now. First thing is to open the file. So open the file. Now, in opening the file, so we have to go to the location where our data, our file was stored. Yeah, I think also I used to have it. Could be here. Where is my WEKA, as the case may be. Yeah, have it here. Okay, I have the data here. You can see, even though this is where I stored the data, but I cannot locate it. No data is here. So sometimes you can face this challenge. Just go here because here WEKA is looking for ARFF data file. So you have to specify here that no, get me all. You can say, okay, show all for me, or just give me the CSV file. Tell it to show me all file. Then you can get many files there. Or specifically give me the CSV file. Then it will bring out the CSV file only for you. And then we can load the data set. Now the data set is in your WEKA environment. So modeling can start now. So you can see here, you can see the target. Yeah, you can see the target. Yeah, this is the wrong file now. I've opened the wrong file. Why? Because the target is still in number. This is what I explained earlier. It was good now I opened the wrong file. You see, I opened the wrong file. The one before we could do we carry out the conversion of target to yes or no. So you can see here, it's assuming that it's a regression problem. So that is why it's giving you the minimum value for that attribute is 0, maximum is 1, mean and standard deviation. The same thing that is done for others will be done to it because it is seeing it as value, not as a classification problem. So that's why I have to go back now to load the correct file, which is the one that has been changed to yes or no, as the case may be. So now you can see the difference now. So these are the other attributes. There are 13 attributes here, apart from the target. Now this is the target. Exactly. Because we have replaced 1 with yes and 0 with no. Now it's telling us that we are having yes, 14,274, no, 11,809. Now this is your data set, this is the visualization, this is the distribution. It's not balanced, but yet, this is not our concern for now. Let's even see what the data is going to tell us. Let the data speak. Because sometimes even though data is not balanced, depending on the nature of the data set, if the imbalance is not too much, it might still work for you. Now, so once our data is here now, so the next step is to go, you can see any other data, this is the sec, this distribution. So, I mean, yeah, as the case may be. Now, since you loaded the data and the target is on the right side, it's automatically assumed that this is your target. Now, irrespective of the name doesn't have to be target. It could be Y, it could be anything. It could be hypertension status, it doesn't matter. But the position in the Excel file is what matters. Make sure your outputs are the last column. We explained this one earlier. Now, the next is go to classify now. Now, we want to carry out the classification. Of course, it has selected the default classifier or algorithm, as the case may be. So we want our algorithm. Let's use our friend, the k-nearest neighbor. So you can, why we don't use the default? Just click start. Or no, because the data is a little bit big. I don't want it to run for a long time. Let's do percentage split. Let's use 70%. Now I'm going to use 70%. for training, 30% for testing, using the default algorithm selected. You see now it has finished. 0R got 55% accuracy. These are the percentage of correctly predicted and the incorrectly classified instances. This is the result for 30% of the data, the one for testing. We did it earlier. It's under how to use WEKA. You can check that out. If you want to see the result of the training, then you need to go here, more option. You have to go to more option and then say that output model for training split. Show me model for training split. You have to go and select it here. Then you can be able to see the training output. But because what we really need is the testing, that's what really matters now, then we only see this. Now 0R, okay, let's see. Of course, we can do parameter optimization for it. And it's one of the algorithms that has no parameter to be optimized. As you can see here, nothing is specified to be optimized. It has no hyperparameters. There are some algorithm like that, like naive-based. There's no hyperparameter to be optimized. Yeah. So they work for some data. If they don't work for your data, then you have to look for alternative because there's no way you can make them better. Now let's look for K nearest neighbor. You can see here, this is K nearest neighbor. This is, let's look at lazy, under lazy classifier. This is IBK. If you just, yeah, this is put your mouse upon it, you can see K nearest neighbor classifier. So I'm going to select K nearest neighbor now. So if I click inside here, I can do the parameter optimization here. Now, number of K is 1. Let us use the default first. Let's just use the default value. Now let's run the experiment. Starts 70%. Yeah, it's taking a little time. Let's see. Yeah, it's done. I'm even surprised it's not more than this. So you can see here, it's done within seconds, even though we have like 20-something thousand samples. So you can see for the testing set, it used 7,825 for testing. Yeah, so, and all of them got correctly classified, 100%. 100% classification. It means for this data set, it's able to determine if someone is going to be hypertensive or non-hypertensive by 100% accuracy. That is really, really interesting to note. Okay, so, and this is just default parameter. If I want to see, then, okay, let me change K to 3, K to 5, K to 7. You know, when you are dealing with binary classification, then the number of K has to be odd number so that you don't have a tie during the voting process. So you can do the hyperparameter optimization also here. You can also enter here to change the Euclidean distance. You can change it to Manhattan, Minkowski, shape, distance measure, and also for that. So we already discussed this earlier on how we can do a parameter optimization in WEKA. So we can refer to our earlier videos. Now, what shows this one is that our lazy classifier K nearest neighbor is able to successfully predict or run a model on this data set and get 100%. To me, this is interesting. Now, let me choose another classifier. You can play with others. So choose another classifier. This time around, let me go to tree. Let me go to tree. Let me see the decision tree, the basic one, the J48. This is a class of, class for generative pronoun C4, J48. I'm going to also use the same default parameter and run for J48. I see what is it getting. So running the experiment. Wow. So decision tree is also getting me 100%. That's interesting. Let me use one more. Let's go to our friend again, Bayes network. See, naive-Bayes. We explained this at the beginning of our discussion, maybe 2001, I remember. So we can check out the video on naive-Bayes, how it works. Naive-Bayes also is another algorithm that doesn't have hyperparameter to be tuned. You can see here, when you see the name here, they will list out the parameter, but there's nothing here, nothing to be tuned. These are just values to set, to control the number of decimal places, whatever. They are not hyperparameter. Hyperparameter, they are the actual parameter that will affect the performance of the algorithms. So naive Bayes is here. Let's run the experiment for naive Bayes. Okay, here we go. Now, for naive Bayes, it's able to get 83.8% accuracy. Of course, there are other, you can see here, the confusion matrix for it. It's having some mistakes. These are the mistaken classification, false positive and false negative, as the case may be. But for decision tree, it's 100%. You can see here in the confusion matrix, everything is on the correct classification. False positive, false negative, 0. The same thing for IBK, K nearest neighbor, the same thing, 0 mistakes, as the case may be. So this data are set up and very interesting in three cases to see as, oh, so is it possible to have this? Maybe because the data is a little bit big, and that's a little bit of interest. For me personally, that I've been working on this kind of area. So it shows that our model is able to achieve, depending on the kind of model you have. I've not tried support vector machine, and there are so many other algorithms there you can try out, as the case may be. But then this is what I call moving from Kaggle dataset to a built model in WEKA environment. So these are you have built models successfully using 70% training. If you like, you might want to try at your own convenience, try to use crop validation. But then I can tell you, you 10-fold crop validation is going to take some time, but it's good to try it somehow. And also, since my data is big, I might want to also divide it into 3. I have training set, I have validation set, and then the final testing set. That is good. You remove the validation set, put it in another file, then upload the training and testing one, and then you can say, okay, use percentage split, 70, 30. Of course, this is a data set of 24,000 plus. You put like 5,000 separate to be used for the final testing, but the training and validation is going to be 20,000. Then divide those 20,000 into 70% and 30% for training and testing respectively. Once you are done with that, you now say, okay, supply test set. Use this option to bring in the 3rd partition now. It will now load the 3rd partition of the data set, the one you put in a separate CSV file that you want to use for final validation testing, or as the case may be. So because we have enough data set, we can afford to do that. So then you want to build it, you want to be sure that your model is not just random, that it is really doing a great job. However, we have discussed a lot on this. What we have done, training and testing 70-30 is acceptable. Especially, we have not even done any hyperparameter optimization. You see, with just default value, it got 100%. This one also default value 100%. This one with default, it doesn't even hyperparameter, it's getting 83. That is the power, how far it can go. And that is why I said our last presentation was on machine learning is not a dogma. Sometimes you have an algorithm that is good in some area it might not work. See, we have used KNN on some very simple data set, it doesn't even work. Maximum of 50%, 60%. But here it is, a very, very standard data set, huge data set, and is getting 100% correct classification. So once again, so I hope we have able to demonstrate how we can move from getting raw data from Kaggle and then to build to a built model in WEKA. So that's how we're going to have it for the day. So we'll take a couple of questions as the time may permit. So thank you very much.